Now that we've got some basic data types down in structs, and soon we'll do classes, there's another data type that is very important in C++ called pointers that you need to know about. So a pointer, we've kind of dealt with this a little bit already. So arrays, when I have a char array, for example, name here, this is actually secretly a pointer to the first character in the set of 20 characters. So when I'm actually referring to name, I'm referring to the memory address of that particular location. Now we've been kind of setting particular, I suddenly realized I should probably call it student name. We've been doing particular numbers of characters here, but what if we want to actually change the number of things in an array at runtime? One way we can do this is a character pointer. So let me show you kind of the syntax behind a pointer. So the first thing is, let's say we have an integer and we want to point to it. So notice the star here. You can put a space here or not. It turns out it doesn't matter. So this is a pointer to an integer. It is actually a special data type called a memory, where it has a memory address of an integer. So things that you can set a pointer to. I could set it equal to 0, for example, and that's probably the best thing to do if you have nothing inside of it. Another option is null in all caps. You either have, if you've imported IOStream, that's already been defined for you. Another thing you can do if you don't have IOStream is define null as 0. So another, and that's something that those of you that are Java users are used to. That probably makes sense. Basically, you have to have some sort of thing that sets up a pointer equal to a memory location. And we usually use 0 by default if that pointer is actually pointing to nothing. So how do you assign things into a pointer? So let's say that I want to actually set this to a particular value. How do I do that? So if I just want to set this pointer to an int, so let's say I have some sort of value, I say it's a 5. How do I set a pointer to value? So I might try doing that and say, all right, give me back whatever pointer is. And we get a error message which basically says you can't convert an int to an int pointer. So this is a memory location as it is, and so we need to actually set it to be the address of a value. So this particular symbol here is the address of something, and at the ampersand. So this is the memory location of the variable value, wherever that's located in memory. It was created here, assigned some memory location. We put 5 into that memory location, and this is giving us the value back. So if we have the pointer, which points to a particular memory location, if we try and do just this, where we just print out the pointer, let's see what that does. So this prints out this weird hexadecimal value. So this is actually a binary location, but it uses an encoding called hexadecimal, where each of the digits here can be 0 through 9, or A, B, C, D, E, or F. And so an A is secretly just a 10, a C is actually a 12. And the reason they do this is that you can actually encode 4 bits in a single hexadecimal digit. So we don't want the memory location of pointer. Let's say we actually want to see the 5. So what we have to do is we have to do this thing here, a star in front of it. This is called a dereference. So now instead of printing out the memory location like I was doing here, I'm printing out what is in that memory location. That's what a dereference does. So now we get the 5 back out. So what if we want to create instead of having this extra step here of this value of 5, what if we actually want to create just space for a pointer? So instead of doing value here, you can use this special keyword called new. And just because I'm curious, what is this going to give us? This gives me a new memory location, and then I can put things into that. The reason this is of interest is I can have this run like in the middle of a program. I can actually create new space for pointers, for character arrays, new structures. So all of these things can be done at runtime instead of just at when I'm trying to figure out how many spaces I need before the program even runs. So this isn't as interesting with a single integer, but it's a lot more interesting when I'm dealing with arrays, which I'll get to in a minute. Now, one thing you got to watch out for. When I'm done with this pointer, it sticks around in memory. So this new int that I create here, it's still in memory when the program ends. And so you can get something called a memory leak, where if I'm no longer using this pointer, I've still used up this space. This isn't really a big deal on the small programs we'll be writing, but in bigger programs, what will happen is over time you'll eat up more and more and more RAM and eventually cause a computer to crash. So when you're done with a pointer, what you should do is you should delete it. So that will actually delete the pointer, and then it's always good practice to then set the pointer equal to some value that isn't actually a reference. So that prints it out. I delete it afterwards, so I no longer have this extra new int sitting around in memory. By the way, when I say delete pointer, delete actually deletes the thing that's located at that pointer, but it doesn't delete the pointer variable itself. So this is actually deleting things at that memory address. All right, so let's talk about arrays real quick. So we have this character array name, which has 20 spots, which means I can put 19 characters in there with a null character inside of it. What if I don't know and don't want to allocate a bunch of space beforehand? What if I want to just read in whatever's I can and then use that in my code? So this is the idea of a dynamic array. What we do is instead of using an array of static size, what we do instead is we create a char pointer and then some way of keeping track of how many things are in that particular array. Now you can use pointers, char pointers, or int pointers, or whatever other pointers, using array subscripts exactly the same way as arrays actually use them. It turns out an array is secretly just a char pointer to the first address in memory. So if I want to actually allocate 20 spots for this name array up here, what I can do is I can say name is well, let's do this first. Let's set size equal to whatever it's going to be. So let's say that we set our size to 20. Name then is going to be a new char array of a particular size. So what I can do is I can figure out how many things are supposed to be in the input while it's running. So if the user can put in basically anything. And then what I would do is I would not put in a particular 20 here. I would actually figure out how many characters they read in and make an array of the appropriate size. By the way, for deleting arrays, so if I wanted to delete name up here, you delete arrays using this notation where you put brackets in front of it. And once again, then you would need to probably want to set this to null, because otherwise if you try and reference that after you've deleted it, you'll get a segmentation fault. All right, so what if I want to read a particular character out of here? So let me cin name. I guess I have that right here. What if I want to read in the first character out of name? You can actually use subscripts the same way you can with arrays. So that'll print out the first thing in this. And if I do a 1, it gives me the next one. So I mentioned dereferencing before. When you use subscripts like this is actually a dereference automatically. So it basically goes to the one slot in name and dereferences it, meaning like it goes to the one slot in name and grabs the value that's contained at that memory location. So using the subscripts actually is dereferencing it. So I don't need to use the star in this case. It's already taken care of for me. It turns out you can actually do pointer arithmetic as well. So I could do name0 plus, well, let's see, how will we do this? Let me create another int, which is count, and set it to 2. So what does this do? So I say name0 plus count. Let's see what happens. I typed in a different thing, but 0, 1, 2. So it actually adds on 2 characters worth of space, goes to that thing and dereferences it. So you can actually do addition to jump down memory locations. Every time you add 1, it jumps 1 data type's worth down into the array. So since I'm using chars, adding 2 onto this pointer jumps me 2 chars into the array. I'm sorry, it's this one, 2 chars into the array. That's called pointer arithmetic, and you can use that to basically simulate 2-dimensional arrays as well if you wanted to. So for example, you could multiply by some number of rows and use a single-dimensional array to represent 2 dimensions. So for example, if I was doing tic-tac-toe and I had 9 of these things for the 9 spaces, I could multiply by the number of rows and then add the number of columns, and I'd be able to simulate a 2-dimensional array with 1. Okay, so what about structures? I've got the structure here, student. You are allowed to have pointers to structures as well. So let's see, if I have student, my student, so I create one of those guys, what can I do with that? So let me get rid of some of this extra stuff. So if I want to actually, this is creating a new student. That's the way that you create one. It actually allocates space there. What if you want to point to a student? You can actually do the same sort of thing. So I could have a pointer to a student. And then if I want to refer to something in the student, if I was doing my student, let's say student name, I would do this. So I could say something like this, where I would say you do dot student name equals this. What about the pointer? So a tempting thing to do would be like, all right, so pointer dot student name. So that kind of makes sense, right? Same sort of thing. You dereference your pointer to get the thing that you're pointing at, and you get the student name. So just to show you that this does work. Oh, I need to point to this guy's address. I'm not allowed to assign a value directly. Let's do a cin into this thing. That'll work. It's a good thing I tested this. Okay, so we get George. What about if we want to do the pointer? So ideally what we do is the same sort of thing. It throws an error. Why? So here's a problem that comes up with this particular notation here. It turns out the dot operator is applied before the dereference. So what it tries to do is it tries to do pointer dot student name and then dereference the whole thing because the star happens later. This is a pretty common thing. So the way that you can take care of this is you can either use parentheses, so basically meaning go get the student and then grab his student name. Or you can use the shortcut, which is this, an arrow. So a dash and then a greater than sign. What this does is it dereferences the pointer and then goes and grabs the student name. So if I can save that, now it compiles. Okay. So one reason that you might want to do this is, let's say that we want to have some sort of method that takes care where we pass in a student. So let me create a void set GPA function. And what I want to pass in is a student, and I'm going to have the student automatically have its GPA set. So let's say we have something where we want to set them all to 0, for example, for all of my students. What I would want to do is I would want to probably pass in a student, maybe current student. So if I do this, and then down here, so remember, function prototype, function. GPA equals 0. And then in here, I'm going to call setGPA on my student. I should pass that in the parentheses. And then let's see out what my student is, the GPA. Oops. So I enter my name, and then it gives me this. Well, that's interesting. My student's GPA got set to some weird value. So the reason why is that current is a copy of my student. It's not the original student. So if I alter the current's GPA, that is altering the copy of this. So just to remember reference and value, the student is being passed in by value, which means it copies the student and doesn't alter the original one. So passing in my student passes in a copy of it. It doesn't alter its original one. Probably an easier way to do this would be to actually pass in a pointer to that thing. So if I go up here and say, all right, current is a pointer, and then change current's GPA, and then instead of my student, let's say I pass in the pointer that I made earlier. Oh yes, my student now needs to be, current is now a pointer, so I need to change this to a dereference that way. Now I've actually altered it. So those of you that are used to Java, this is basically the way you pass things in, is basically change them into pointers instead of passing the original structure. Now the other reason you would want to do this, so let's say you just wanted to pass in the address of a student. That's another valid way to do it, but pointers use a constant amount of memory. So you use less memory when passing around pointers. So when you actually are dealing with, for example, vectors of students, you may actually want to start dealing with vectors of student pointers instead, so that you can actually pass them around. Basically, whenever I use any kind of structure, whether they be classes or structs, whenever I'm starting to set up parameters, I almost always pass pointers back and forth instead. All right, so that is a quick tutorial on pointers.